In today's webinar, we're going to be looking at getting the perfect tolerances for your 3D prints. And the problem really is quite simple. Most 3D prints come with multiple pieces. You're going to have multiple parts that attach to your object. And sometimes, unfortunately, those parts could fuse together. They could be hard to assemble, might be hard to actually put together. Or on the other side of things, it could be too loose. It's so frustrating because when we design it, we might design it perfectly. It looks all great. But then when we print it, maybe sometimes it works, maybe sometimes it doesn't. Maybe with different materials it works, maybe with other materials it doesn't. So it's a really frustrating problem. And it's something that I'm going to cover today. We're going to be looking at why tolerance is an issue, how to completely fix it, and then what doesn't work. So what you shouldn't change if you want to actually get your tolerance right. So firstly, the theory and the definition of tolerance actually is defined by you and your application. So looking at these three pictures, we've got these fidget toys on the left here, and we've got interlocking features. They can be quite loose. So if those interlocking features are slightly off, it probably doesn't make as much of a difference than if I look on the part on the right, which is part of a car engine that has to spin absolutely perfectly. It's got to be like really, really balanced, and it's got to have really high tolerances on these pistons. So we have totally different requirements, and that is defined by you. So tolerance really is how much wiggle room do you have for your application? And there's a difference between tolerance and accuracy and precision. So I want to show them to you now. So accuracy is when we're talking about how close is the part or the measurement of the part to the intended target. So if I design a cylinder to be 10 millimeters in diameter, when I print it, how close is the diameter actually to that 10 millimeters? That is called the accuracy. And if I just use a bullseye example, hit the bullseye here, right? So I've got a measurement that is extremely close to the intended target, but this little red circle here that I've put here, that is my tolerance. That is my acceptable amount of wiggle room. And you can see that even if I was slightly more off, I would still be within this tolerance. So the tolerance, that dashed circle, that can be a lot smaller if your application requires it, or it could be a lot bigger, again, if your application doesn't require as much accuracy. Precision's a different thing entirely. So especially if you're making multiple parts and they all need to have the same function, then precision is really important here. This is, if I repeat the actual print, how close together are all the measurements? That is the repeatability of a measurement. So you can see here that these three dots is my measurement, and they're a little far away from my intended target, which is the bullseye in the middle. But this is precise because I'm getting consistent measurements that are all within a very small area here. So we've got some definitions out of the way. So now how does this actually apply to 3D printing? So you could have an accuracy or a precision issue. That is the key takeaway here. And this changes the solution you choose. That's why I've chosen to define them, so to help you understand, because the actual performance of your parts could be affected by either an accuracy issue or a precision issue. And just to give you a little bit even more theory, when we're actually printing, why don't we get the exact dimension that we're after? It's really simple. We're using filament, and when we heat up any material, the material expands, and then as it starts to cool, it shrinks, okay? And this alone, like just this one part of the printing process alone, which is the foundation of it, will mean that there's some variation in how it cools, and therefore there's some variation in where it cools. So that's why we don't always get the plastic being exactly in the right spot. We always are going to be designing something perfect on the computer, but then in reality, we're going to have some variation. And that this is just one area where you get that variation. There are heaps of other factors that affect printing. So one of them is ambient temperature and humidity. So probably humidity, not as much, but it does affect the cooling rate. But obviously the temperature plays a big role. If I print something overnight and it gets to 1 degree outside, then it's going to be totally different if I print it in the day in a room that is like 20 or 25 degrees. So the cooling is going to be much different. Therefore, again, we get different variation in where the plastic is going to cool. Then obviously the material. So different materials behave differently. Then obviously the printer cooling itself. So this is the actual use of fans. So some printers have enclosures. We could have auxiliary fan or just the fan pointing at the nozzle, and the speed of that and how effectively that airflow hits the plastic and cools it down is going to make a difference. And even just like the part that we're printing could affect the airflow around it, right? Because we could have internal features that are kind of shielded from that airflow, or we could have external features that maybe feel that airflow a little bit more, especially if we have auxiliary cooling. Then we even have the mechanical tolerance of the machine. When I started 3D printing, the machine chassis was held together these threaded rods. The tolerance of that machine is way less. The accuracy of the actual movement and the motors and all the pulleys was less than the machines that we have now. Okay, the print speed as well, that can affect the cooling rate. If we print really, really quickly, then we might have quicker cooling as we're moving the plastic. Maybe the actual temperature of the plastic doesn't even get as high, right? Because it might not spend as long in the nozzle. But there's a lot of factors that go into like print speed and flow rate. Nozzle diameter plays a massive role in accuracy. If we go up to big nozzles, we might not have the ability to get into finer like details. That's one way. The cooling rate is going to be very, very different. a 0.6 millimeter nozzle compared to a 0.4, I mean, you're pushing out like, heaps more plastic. Like it doesn't seem like a big difference, but it is. So for the cooling, it makes a big difference. And then obviously, bigger nozzles can't get into like little gaps and like follow the surface of your design as closely, because usually we're going to be printing with bigger layers and chunkier line width. And then slicer settings themselves, so like layer height, extrusion width, a lot of these settings affect the repeatability of your prints. And then even first layer accuracy, if you need the tolerance to be right on the layer, and a lot of people here will probably be printing articulated things or parts that are prints in place, then we just got to make sure that first layer is perfect, because if we have any like squishing, then that could change the accuracy of that part on that first layer as well. And then geometry of the part and orientation. If we print a circle that is in the XY direction, the actual way that it prints it layer by layer is different to if we printed it horizontally, right? So it would be way more accurate if we print it standing upright, the cylinder, because every layer is just a perfect circle. But if we printed it lying down, then every layer becomes different. We have like a lot of overhangs for the bottom of the cylinder, so the accuracy goes way down, right? So all of these affect your tolerance. There's actually quite a lot. So today I want to make it simple for you, right? So what's the solution? First, and I've said this in a few previous videos, we need to optimize our filament settings. We need to do a temperature tower to get the right temperature. We need to look at doing a flow rate calibration to make sure we're getting the right amount of material coming out. We don't want to be over extruding or under extruding. We want to be looking at flow dynamics. So when the nozzle changes direction, there's a certain amount of time that you have with lag. So that is what flow dynamics will help fix. And you can do the flow rate and flow dynamics calibration in Bamboo Studio. And then also retraction test. So if we are printing a lot of parts, we need to make sure that we're not changing our flow rate too much because of the retractions. We need to really dial in those settings. So that's step number one. What that does is it gives you the right amount of material extruded at the right time, and it cools in the right place. Now for tolerance, right, and the accuracy that we need here, the right place is what is the question mark here. And that's the issue that we could be having. So to get the right filament settings, you can just buy filament that has the right filament settings. So like Filiform, you can just download the settings and we've already optimized it. You might want to fine tune it from there, but that'll get you 90% of the way there. That is the filament settings. Now we need to talk about the actual solution here. And the actual solution could stem from two places. I'm sorry, I don't have my animations here right now. It could be a precision problem. So let me walk you through the main three things that could cause a precision problem is variation in hardware, variation in environment, or variation in software. So basically physical things, software things, or the environment in which you're printing, right? I'm not saying much there because I'm saying the variation could be caused by anything. A few of the key ones that I often see, and this is where I've put it here, if we have a variation in hardware, for example, that could be, say, the actual material itself. So keeping the filament dry is a big one, because how moist the filament is can affect the cooling rate and also how much it expands. Any moisture in the nozzle will help the material actually expand, which is something that we want to avoid. And then a big one that it really does help, like here, this isn't a nice to have. You should really be doing this all the time. Like it'll help so many different aspects of your 3D printer and your printing process, is ensure the maintenance of your machine. What is the maintenance? We need to like lubricate the motion system. We need to like clean dust and stuff away from like the fan so the cooling stays consistent. We need to make sure that the rubber feet and like the base is sturdy. We need to run a calibration sequence every now and then. So all the Bamboo Lab machines, like you can run a calibration sequence to do like noise cancellation, and the auto bed level, you'll like touch like heaps more points. Like, so there's a lot of maintenance things that we need to make sure that we do, even cleaning the nozzle, replacing the nozzle, even the nozzle is consumable. In variation in software, making sure that we're saving the exact same settings. So when you open up Bamboo Studio and you apply different settings to your part, or you download a model, then those settings could change from print to print. Like you might download one designer's model and that comes with the settings. You could download someone else's model and that comes with a different set of settings, right? If you don't want variation, you need to just use the same settings every time. You can save the actual settings of the print process. You can save the settings of the filament settings, like we talked about a little bit before, or just to make it really, really easy, you save the entire 3MF file, the entire project, which will just capture all those settings for you. If you want your parts to be really accurate, you need to print them in the same orientation and as much as possible to be really, really well supported. Ideally, it's printing on the print bed itself or on top of the actual parts. So if you have parts like hinges that require support to actually be held in place, then that is not as good, whereas if the hinge was, say, on the print bed. And then any variation in environment. So we want the same printing temperature and same printing humidity and wind, and I probably should have put a few more things here, but we don't want massive changes in our printing environment. And this also includes, I actually probably should have a bigger list here, like vibrations and stuff like that. So if I've got the printer on a table and maybe I'm walking past it every now and then, and it does experience some vibration, that is going to change the printing environment, right? So when you really want to dial things in, if you're having issues with precision, this is what you have to do. And just to remind you, precision is an issue with the measurements being different. So you might print a part that sometimes works and sometimes doesn't, right? And therefore, these red dots will start to spread out. Some of them might be on the bullseye, some of them might not be, right? So if we have that issue, then we have to look at at these things, okay? But alternatively, if we are just not getting the right accuracy, if our part is simply not close enough to the intended target, like that hinge, it just gets jammed all the time, or it's just too loose, right? Then this red dot is always sitting outside acceptable tolerance, then we've got a different issue. That is an accuracy problem. So what we have to do first when we have an accuracy issue is we got to check, I've done everything I can to make sure that my precision is good. Then I can either do two things. I can adjust for the error in the design, or I need to make sure that I really dial in my filament settings and some of my other settings, because maybe I need to really make sure that the plastic cools in place. So maybe I would even add probably some lines here, like lower the print speed of those outer walls for those really important features. Right? So if we lower the print speed, we might be able to lower like vibrations. It's not always going to work though, right? And this is why we need to sometimes understand that 3D printing it's not going to give us the insane high tolerance that you get from some other manufacturing processes, okay? So sometimes we need to process, and we need to include the fact that we might not get the perfect tolerance in all print orientations with all materials. And what some designers do is actually design their 3D prints to allow for a bigger range of tolerances. Some people that will assemble parts together and say it's a shaft and a hole, like they're pushing a 3D printed shaft into a 3D printed hole. The hole might have little fins on it that help flex. So when the shaft gets pushed in, it like pushes against it, right? And that increases the tolerance range that you can have for that part, right? Because it's more forgiving, right? There's more wiggle room. Now, not everyone has those design skills, or maybe you're starting with an STL. It's harder to actually like change that design. And that's why you need a few different options here. All right. So how do you actually do this, right? How do you test this for your machine? Now, here's the real takeaway, like from today, is that there are so many variations, right? And things that can affect if your parts will fit together or not, right? Here is a print calibration test. We really like using this at 3D printing. We found it on MakerWorld. There's a lot of different things going on here. You've got different overhangs. You can do multi-material. You've got clearances. So this is 0.25 millimeter clearance. You can see here, you've got 1.5 millimeter clearance and 0.1. We've printed this with many different materials. When we print this, for example, with PLA, just normal filiform PLA, we can print this with the optimized settings, and the gap of 0.1 millimeters will rotate. This little yellow piece here has a shaft inside, and that piece rotates, right? If we go and print this with silk PLA, that fuses. Exact same design. Optimized settings for silk as well. If you've ever printed with silk PLA, like it expands more and then it shrinks a lot. Like it has like something in it that makes it like, it basically moves more when you print it. But the 0.15, it'll spin with the silk, but it's a lot more resistance than the PLA one. So same design, same printer, optimized settings, right? But then we get different results of the actual size of these parts. Does everyone know what I mean when I say 0.1 millimeter gap? Probably should have put a stick on the screen here. But basically, if you've got a shaft in here, then that shaft might be 10 millimeters. And then the hole might be, in this case, the 0.1 millimeter here, the hole is 10.1 millimeters, okay? So the difference of 0.1 millimeters will allow a PLA part to spin there. But with the silk, it won't, right? So if I did this for silk and I needed to print this part in silk, I would need to modify my design. Our techs actually, when they're troubleshooting machines and they need to really dial into an issue, I'll print some of these test calibration models and actually stick it onto the machine. And then when they're making stuff, they might do this for a few different machines, and then they'll realize the machines is different, right? Like what the actual behavior of these pieces, same design, printed on different machines, same settings, will yield slightly different results sometimes. Yeah. And that's just because the machine actually itself is different, right? Ideally, it's not, but physically, like there are some very, very small changes. And if we're only talking about 0.1 millimeter gap, right, it only has to change by like 0.01 millimeters to make like a 10% difference, right, to that. So it's really easy for small changes to happen. And that's why doing a tolerance test on specific machines, if you really need to dial it in, is a good idea. So all-in-one test print. Let's have a look at this. So download it, open that, and you can see here, it all prints in place. See here, it says it should be 70 millimeters from here to here. So that's a tolerance that you can measure. This one has the 0.25 millimeter gap, 0.15, 0.1. We've got these little knobs at the bottom here. These are meant to like push in and push out. Like they shouldn't be fused. They should be able to rotate. And you use this key here. This is actually like it pops out, this M thing here. And it's got these little keys that actually rotate this part and this part in here. You literally just print this with your settings in your print conditions. And if you have problems with this, then you can troubleshoot it, right? You might realize, oh, it's sticking with the 0.1. And in my design, I have a 0.1 millimeter gap, and that is an issue, right? I've done a few videos like this. So we've done bridging best settings, we've done support best settings. And in those videos, I say, don't change the temperature. So changing the temperature affects so much of the print process. We could be affecting other things. It's just such a big thing to change. With tolerance, I would say it's the same, right? There, we really got to understand, why do we get the variation in the first place? Or why are we not getting close to that target in the first place? And temperature is if we keep it, say, for PLA, 230 degrees. If you did lower the temperature, your flow rate won't be as high. So you got to put your parts way slower. And sometimes that's fine and you can deal with it. And it really comes down to like what you're doing this for. You'll have different rules for, say, PLA than silk. So with PLA, we would say you can go down to a 0.1 millimeter gap between a shaft and a hole, and no problems, you'll be fine. With silk, maybe not. Maybe the max is 0.15 or 0.2. So I wouldn't be touching temperature for this. We have a school community that has heaps of free courses. You can post here. We do weekly events as well. And we've got a lot of these free courses, design tips, these weekly webinars. I put the highlights on here. Splicing tips, we've got a free business course. So thank you for joining. I love that we got to hang out today. Go and print the future and let me know if you have any questions.